So how 3D machine vision and edge AI can help here. So when we look into the mines or the quarries here, we almost see a lot of technology has been implemented in different stages. And we just don't realize how impactful it is until we go and dial down each use cases, separately here. But this just entails how, from the technology implementation perspective and the sensor and the data, it's been capturing every day and day in and day out. But it's only in the aggregated form, which means the data is being captured, but the intelligence level is not been created on a daily basis. So when we think about the mine here, this graphic is from Nokia, which is essentially entailing the different sensors that are implemented in the mines and where the evolution is also going. So the drones are becoming ubiquitous now, but we're also seeing autonomous haul trucks, asset monitoring and different equipment, geo-tagging and geofencing of the assets. We are looking at the analytics space on how this predictive maintenance can be done for the operations equipment. So all these technologies already continue to be a major part of the mining and the quarry operations here. And once there is a lot of data, we start to see the aggregation of the data happens, but the intelligence layer always is where the bottleneck comes. So that's where I want to focus a lot more on how the edge computing can help create this intelligence layer real time. But before we dive into that, let's understand what's the evolution of these technologies are, because the machine vision comes from the imaging side of the technology bucket here. So we have to understand what that means. So we know that there are 3D imaging, what we see in terms of the display, and then there is a 3D sensing and recognition and detection side of the imaging. So when we look at the imaging, which is the stereo images, which can take photos from multiple angles and generate 3D digital twins. You have 360 images, which can be used for any inspection or just looking at the visual aspect. And the image processing, where you are looking at each pixels and rasterizing or vectorizing them to understand different measurements technique. Then you have the holographic images, which are looking at projecting an image and understanding and visualizing the different components and different aspect of your either asset or either just a digital twin there. So those are on the imaging category. Now we think about the 3D sensing, which leads to different understanding of perception, recognition, and detection side. So one of them is the mineral recognition. So another level of sensors of the imaging or camera sensors is hyperspectral or multispectral, which leads to understanding of different components and the spectral signatures of the minerals, which has heavy use on the deposit detection. Then we have also seen the applications in the equipment health detection side. So either a camera sensor or the sensing the sensors can be applied into equipments to understand not just the health, but also where are the potential damages can occur way in advance. We've looked into the sensing components into the ADAS, which is the automated driver alert systems, which are nothing but understanding the visual components of the surrounding and generating a spatial awareness, and then it sends what are the different conditions, from the driver alert needs to be built. And we also see the detection in the AR and VR side, which is the augmented reality and virtual reality. So if we can simulate the actual mine environment or quarry environment before we actually make any decisions, what will happen? So it's a projection of the outcomes. And in this case, the blasting use cases could be understanding of what not only the bench models are, but also what type of explosives energy will have an impact. What's my drill hole conditions are there? What's my floor conditions are there before I start to load the holes? So those are great use cases for the AR and the VR from the detection and creating awareness side. And then we have also seen the obstacle avoidance, which is, again, there are sensors built in to understand and avoid things there, which leads to a third category on the sensing side, which is the situational awareness. So if I have a sensing equipment, which is the cameras supplied in several different directions, we can build situational awareness. So it means a machine can understand what's this awareness around that equipment. So two machines or three machines can talk to each other and understand about their own positions. We see these applications often in the robotics. So for today's discussion, we're going to talk more on the sensing side, which is our range of modality here. And this 3D image and sensing covers a wide array of modality. What we're going to cover in today's presentation is a lot more on the optical 3D side, which is a structure from motion, stereo cameras, and projection-based cameras, which is what the machine vision is. But there are other types of modality like X-ray scanner, CT scanner, where you see and understand the geometry and the physical aspect, data capture. And also we will see the aspect of LiDAR in today's presentation. And there are different types of LiDAR, which is solid state flash LiDAR. What we will not cover today is more on the radar and the SAR systems here. So things to know more about the edge computing. So we looked into what machine vision components are and how it has evolved. And when we think about the edge computing, which means it allows the computing and the processing of the data real time at a local servers. That's what the edge is. So all the packaging of the software and everything, it has an ability to understand and move the data real time and understand and give an intelligence real time here. So processing power is physically close to the sensors. In this case, it's the camera sensors. And that's where we see a lot of applications in the mining side, where a lot of innovative use cases can be built, because mining always deals with low latency situations, which means you don't have a high bandwidth, you don't have a good network, and you need to process the data real time. And you need a good rugged environments to process this data. And in order to build these situations where the data can be processed, the edge computing is the perfect fit there. When we think about the AI itself, where it has moved in the maturity curve here, and this is a guideline from GMG, Great Mining Group here, where they published about what are the areas when we think about the AI applications where it fits. So assistive intelligence, which means AI can execute the task that would be done by humans, which means I have A plus B related tasks are there, and what that deterministic outcomes will be. You train the model, you determine the pattern, and then the same pattern gets repeated time and time again. And decision making is always in the user's hand, whether to recognize that the pattern that's been developed by the AI system is accurate or not. Then you have the augmented intelligence, which means it's combining the human intelligence and the AI to learn from each other, which means it's a supervised models can be developed, but it also empowers the human to generate different type of understanding what AI machines are generating. And then a combination of human intelligence can be applied to see what has been missed. So new insights can be discovered from there. Then there is another level of intelligence, which is the autonomous side. The AI system is capable of acting on insights generated by itself. And we see that a lot in the self-driving or the haul trucks, which are being autonomous now, which can understand and see and stop. We see a lot more in the robotic side. So the maturity curve at the moment in the technologies where we are a lot more at the assistive and augmented side. The autonomous is still at the stage, it is still evolving to get it at the level where they can be applied on a day-to-day scenarios.